welcome back to this Walking Talking mock. We are doing Further Maths 2013 paper 1 and we are on question 13, which actually means we're almost done, right? Because there's only 16 questions, so... Oh wait, did I do... Yeah, I did that one. Okay. Solve y root 3 minus 1 equals 8. Interesting. So, put y equals 8 divided by root 3 minus 1. Okay, so, I mean, I've technically solved it, right? It's solved. This is what y equals. But it's not in the form they want. To get it into that form, I'm going to have to rationalise. So to rationalise something, you times it by the conjugate on the top and on the bottom. And you're all going to be tempted to do root 3 plus 1. But it's not root 3 plus 1. It's minus root 3 minus 1. Because the thing that you negate is the root bit. Yeah? So the numbery bit, you just leave as it is. But the root bit, you do the negation of that. And actually, I'm marking Further Maths A-level papers for edXL at the moment. Which is complete ball ache. I don't know why I'm doing it. But it's the most common mistake that people have made, that I've noticed, is doing exactly this. They're doing root 3 plus 1. Which ruins their entire question. Because like that's such a minor part of the question. Because this is like A-level. And if they get that wrong, then the 7-mark question that follows it, they're just completely screwed. So... we're going to do 8 times minus root 3, which is minus 8 root 3. And then 8 times minus 1, which is minus 8. And then we're going to do root 3 times minus root 3, which is, well, my phone battery is low, which is minus 3. Wait, if you couldn't hear that notification noise just now, then you probably think I'm insane, because I just randomly said out of nowhere my phone battery is low. I'm slowly going crazy. Okay, root 3 times minus 1 is minus root 3. Minus 1 times minus root 3 is plus root 3. Minus 1 times minus 1 is plus 1. Okay, so we've got minus 8 root 3 minus 8 over... Those two are going to cancel each other out. Minus 3 plus 1 is minus 2. Okay, so let's divide everything by minus 2. So that divided by minus 2 would be 4 root 3. That divided by minus 2 would be positive 4. And as usual, I've written it backwards, so let's make it 4 plus 4 root 3. There we go. Okay, ABP and ADQ are tangents to the circle, centre O. C lies on the circumference of the circle. Prove that y equals 2x. Interesting. Give reasons for any statements you make. Are they giving me lots of space? They've given me loads of space. On the back as well? Yeah, and on the back as well. 6 marks. Okay. Let's go for it. So, I'm thinking... Shall I plan it out and then write it down? I think I should do that because, yeah, things could go wrong. So I'm thinking that angle at this centre, so this here is 2y. No, it's not. No, it's not. Sorry. Pretend I didn't say that. It's not. It's not. Right. That's 90. That's 90 because tangent and radius. So that's going to be 180 minus y because it's a quadrilateral, so they all add up to 360, but we've already got 180, so it's got to add up to 180. So, yeah, okay. Right, now that angle there is either the half of that. 90 minus half of y. And I guess nah. I feel like I'm accidentally proving the wrong thing. what else should I say? Oh, that's x. So that's x. Hang on. Let me get rid of this because it's kind of in my way. I'll just keep it in the back of my mind. I'm going to need some colours, I think. Right, that there is going to be x as well. Because it's isosceles, because of the radii. And then I need some more pens. Orange. These two are equal as well, so that and that are the same, but I don't know what they are. But I do know that that's 90 minus 2x because of that. And then I also know that that's going to be, alright, this is going to be a complicated expression. It's half of 180 minus y minus x. Because it's half the angle at the centre, but we already got x of it there, so I need to take that off, and we'll leave the orange bit. Okay, which makes 90 minus half of y minus x. And we know that that has to equal 90 minus 2x, which means that minus half of y minus x equals minus 2x. So minus y over 2 equals 3x, nope, it doesn't, equals minus x. So y over 2 equals x, so y equals 2x. Okay, proved. So now I need to sort of make that make sense to other human beings. So let's say, right, OBA equals ODA equals 90 degrees because radius meets tangent at 90 degrees. Okay, BOD equals 3, right, let me just write it down, equals 180 minus y because angles in a quadrilateral add up to 360. Sorry I keep coughing, my voice is going, I don't know. These videos, they actually kill my voice for some reason. You know I don't talk that much as a teacher. Okay, that's not true. But I'm not used to talking this much. I don't know how Mr. Edwards does it, to be honest. Right, so then OCD equals x because angles in the same... Oops. I just put two E's in the word same. You know, it's actually really difficult to write when you're not looking at the paper, but you're looking through your viewfinder of your camera. It's like writing on an uncalibrated whiteboard, which I'm actually very used to. Okay, then OBC equals 90 minus x. 90 minus 2x. Because angles on a straight line. Add up to 180. Okay, and then BCO equals 90 minus 2x because... Wait, hang on a second. Why did I say that? That's not because angles in the same segment are equal. What am I talking about? It's because it's an isosceles triangle. Oh gosh. It's also difficult rubbing things out when you can't see properly. Okay, because base angles in an isosceles triangle are equal. Okay, same reason. Okay, but OBCO also equals 90 minus y over 2 minus x, because angle at the center is twice the angle at the circumference. I'm fed up of actually forming letters now. This is more writing than I've done in a year. So 90 minus 2x equals 90 minus y over 2 minus x. Take away 90. Let's add x to both sides. Let's make that like that, and then let's make that like that. Let's put some arrows in between. Proven. Done. That's just extra space. Let me just have a drink. That's better. Sorry, that's kind of insensitive whilst you're fasting. Sorry. Okay, express that in that form, so basically complete the square. Okay, I'm going to take the 2 outside and deal with him later. I should say her, actually. Did you know the Greeks believed that even numbers were female and odd numbers were male? I think that's kind of interesting. Well, I said he because this 2 is not cisgendered. I'm going to now do what I do, which is half that. I'm going to square it over here and see what I get. Okay, so I've got plus 9, but I want minus 3.5, so I'm going to have to take away 14.5. No, 12.5. 12.5. If I take away 12.5, yeah, okay. Then they don't want the A on the outside of everything, they want it just on the outside of that. So I'm going to expand, well, not expand, well, kind of. I'm going to distribute the 2, like that. There we go. How many marks do they give you for that? 4 marks! Not bad. It's so much more generous on further maths papers than on normal maths papers. And then the grade boundaries are so low as well. I don't know. It's nice. I had, a few years ago when I taught further maths before, I had quite a few students who did better on further maths than they did on maths. And that was when the maths GCSE was easier. So I have a feeling quite a lot of you in my class are going to do better on further. Well, you can't compare because normal maths is numbers and further maths is grades, so how can you say which one's better? I don't know. Okay, put it this way. I guarantee, I'm telling you right now, there will be more A stars in further maths than there will be grade 9s in maths. Definitely. 100%. There might even be more A stars in further maths than there are 8s in normal maths. Maybe. I'm hoping not, because I'm hoping that a lot of you do get 8s. And I'm hoping that, well, statistically speaking, 4 of you should get a grade 9 in your GCSE maths, out of my class, I mean. But who knows? Who knows? Okay, solve this. Right, so what should I do? I've got a minus here. Right, I'm going to turn that into a improper fraction because nobody likes mixed numbers. So that's 64 over 9. That's good because now I can see some square numbers here. I'm going to unreciprocal this by unreciprocaling this. And unreciprocaling is the same as reciprocaling. So I'm going to do, oops, I got rid of that. Okay. I'm going to uncube root this by cubing this. Ugh, no, actually I'm going to square root first, that makes it easier. I'm going to unsquare this by square rooting. And then I'm going to uncube root this by cubing. Ooh, what's 8 cubed? $512. So x is 27 over 512. Wait, was that the last question on the paper? Is it just me, or was that last question really not that bad at all? You know, I'm loving further maths. What can I say? I'm loving it. Maybe paper 1 is just easier than paper 2. I don't know. Anyway, I think that's... I don't have any other paper 1s to do now, so this will be my last video for today, except... Remember, if you post questions in the comments of these videos, then as long as you post the questions before 6:30, I can make a video response to them if necessary. So far I've got one question, which was Jordan asking, when's the next Swan video? Well, I can reveal that after your exam tomorrow, I will put up another Swan video for you, because I think you'll have earned it. Okay, I'll see you next time. Bye!